welcome to today's section. My name is Sunday Ojingene, and we're going to be looking at how computers works, a gentle introduction for beginners, basically the overview of what a computer system is made up of. So my intention today is to tell you the big overview, the things you think you know and the things you might not know about a computer system, how it processes data, and how stuff in computer system works. So basically, a computer system is made up of two special entities known as the hardware and the software. And I must make it very clear that these two are dependent on each. Without software, hardware is essentially useless, and without hardware, the software is as well as useless. So what is the hardware? The hardware, you can say, is that physical part of a computer system that you can touch, feel, you can see. For instance, you can say your monitor, your system unit, your mouse, your keyboards, and etc. And for the software, these are the basic set of instructions that are administered to help control the basic functionalities of this hardware. So going forward, we're going to be looking at other parts of the computer system. And I must say this, for a complete integrated computer system, it makes use of these basic 5 functionalities to carry out its day-to-day activity. The CPU, the memory, the input and output device, the secondary storage. We'll be looking at that going forward. So for now, let's focus on CPU and memory. So what is a CPU? A CPU, which stands for Central Processing Unit, is the brain box of a computer. It contains the chips that control all the activities going on within a computer system. So for a main memory you can say is a temporary storage device on a computer system. I must say this, main memory are always volatile. And what do I mean by volatile? It's not a permanent storage device. So we're going to be looking at secondary memory devices. These are the devices that you can say are permanent storage devices. They are non-volatile, and it includes stuff like your hard disks, your flash disks, compact disks, your floppy drive, etc. So for the input and output devices, these are basic devices which you use in inputting commands or set of data to your computer system and viewing it. You can take, for instance, your keyboard. Your keyboard is an input device, and the monitor stands for output device. So there are a couple of them, like the mouse, the joystick, the touch screen, and so forth. So for the software, like I mentioned earlier, software also have a category, just like you have different versions and different models and different manufacturers of software. We can say like the monopolious Windows, they have gotten Windows XP, 7, Vista, maybe 8, 10 someday, who knows. And okay, we also have operating systems from Unix, from Mac OS, and so how does a computer system processes data that it is fed into? Does it just get this stuff, churn it like a piece of data and give you output somewhere? No, basically there are 2 ways to store and manage data in a computer system, and these they are in the analog form or in the digital form. For analog, we know all analog means. For some of us that are conversant with oscilloscope or some sort of analog ridges, it's a basic continuous data representation in a waveform. And for a digital means of data processing, it actually depicts the data in an off and on mode. So we're going to be looking at this shortly. Okay, so for that reason, it means that every single imputed data in a computer system is treated digitally, be it number, text, graphics, video, audio, anything. They are digitalized and broken down in a 0 and 1, which is on and off state. So representing text digitally, how do you represent text digitally in a computer system? Now for computer system, it accepts characters, but these characters are treated as digits, basically 0s and 1s. So for instance, assuming you have yes sparks, these characters are actually converted to numbers, and these numbers in turn are converted to bits. So these bits are actually binary numbers called 0 and 1, and you all know what binary numbers means. They are numbers of base 2, which can either be a 0 or a 1. And you can use this to memorize. A 0 is always off and a 1 is always on. So binary numbers, like I said, are always in 2 states, the 1 and the 0, which is the on and the off. So let's see how bits are combined to give us these binary numbers. Assuming you have just a single bit, so you have the possibility of having just a 0 or a 1. So what about when you have a 2-bit? What do you have? You have 0 0 0 1 1 0 1 1. So going forward also you have 3 bits. You can have all 3 zeros down to 3 ones. And for 4 bits you also have 4 zeros down to 4 ones. So these are combinations of bits to give us number. For instance, like 0 here actually means 0 and 1 here actually means 1. And the same thing here, 0 0 0 0 4 0 all means 0, but then the combination of the other bits gives you various number. Like when you consider bits, 3 bits, you have 0 0 0 0 basically down to 1 1, and this depicts 0 1 2 3 4 5 6 7. So now let's look at this bit combination. How do we actually achieve the number of bits with a certain number of combination of m bits? Now for every m bits, it could be 1, it could be 2 through infinity. That actually tells you the number of zeros that you're going to be seeing, or the number of combination of zeros and 1 through all ones for the number of bits. So for instance, assuming you have 1 bit down to 5 bits, what are your expectation for 1 bit? What will it be? Basically it will be 2 raised to the power of 1, which is 2. Good stuff. And for 2 bits, can you guess, or can you tell me the answer? 2 raised to the power of 2, which is 4 bits. So going down, you have same thing true for 2 raised to the power of 5 up to get a 32 items. So we're going to be looking at also how we achieve the numbers based on the 0 and 1 combination. For instance, taking 101, it means that for every one starting from the right to the left, for 101 you can say that 1, which is of the form 100, is 4. 0, which is of the form 00, is 0, and 1, which is of the form just 1, is 1. So when you combine 4 plus 0 plus 1, you're actually having 5. And same thing goes for 7 as well. So for bit combination, how well can we do better with this? I mean, like for instance, with our palm, can we get, let's go back to the old theory. What combinations can we get with our palms? What maximum numbers can we get? So let's see here. So with our palm, we can actually get up to 31 bit combination. And what do I mean by that? From 0 through 4, you can do a 2 raised to the power of 4 to get 16. But then as well, since we have 5 palms, you can do 2 raised to the power of 5 to get 32. So bit combination is a bit trick, but it's very simple when you understand the logic behind it. This is an example of what you can do with your palms in terms of bit combinations and notations. Now, what number is this using our thumb? And from the diagram here, you can see our thumb is 0. So if our thumb is 0, it means the number should be 1. So okay, good stuff. The number is 1. Okay, this will be a bonus in this video. For anything raised to the power of 0 is actually equal to 1. So sorry. So going forward as well, you can see for other fingers, the index fingers, what is it? From our diagram, it's 1. So for 2 raised to the power of 1, also we have 2. So let's see, is that correct? Yep. So we have 2. So let's move ahead. When you want to go buy a computer system, what are the stuff you should look at for? What are the specifications you think you want to see? And what are the things that convince you? Okay, so I have come up with a very list specification for getting a personal computer. When I mean, you can see I highlighted in red is actually the list of what you can get. In a jet age like this, we've gotten series of specs. I mean, when you see those specs, this is nothing to be compared with what we have today. So for a list specification of a personal computer, you can think of something like a 2 gigahertz Pentium 4 processor, 512 megabytes RAM, 80 gig hard disk, a 48 CD rewritable drive, and a DVD-ROM combo drive basically, and a 17-inch video display, which is a monitor the screen, and a 56 kbps modem. But what does all these things? So let's see what it means here. Memory is divided into many memory locations, and each are treated as a cell. Let's look at it here. Assuming we have 9278 down to 9286. When we have data, how are these things stored? Okay, let's look at storing information on these memory locations or on these memory cells. Now, assuming you have an input, each memory takes a set of numbers and stores it in an 8-bit, which is 1 byte. So what happens when you have more than 8 bits or more than a byte? Does it do away with the rest, or let's see, what does it do? It takes more of the cell consecutively to store your data in your memory location. So storage capacity, we'll be looking at the units of different storage capacity and the memory details. Like for instance, we have the kilobyte, megabyte, gigabyte, terabyte. These days we have the petabyte, the zettabyte, and the yendabyte. So, but what are the symbols of this? We have the KB, MB, GB, and TB. So when you say KB, of course it's 1000, but with the number of bytes, which is 10, you do a 2 raised power of 10, you have 1024. And then going below, you have over a million for megabyte, over a billion for gigabyte, and over a trillion for terabyte. So memory, we're gonna come back to look at memory again, because really everything about a computer system deals with memory, and memory is very important when you talk about a computer system. Now, like I said earlier, memory is part of that 5 things that are very essential in the day-to-day activity of a computer system. But this memory, how do they function? What are the relations? Do we have different types, and how do they work? Like I said earlier, we have the primary and the secondary, and you have to understand the primary is volatile, whereas the secondary is non-volatile. What defines the volatility of this memory? Now, what defines the volatility of this memory? Is it because it is called primary or secondary? Now we shall see. Not really, but of course we have these two terms known as the RAM and the ROM. The RAM, which stands for Random Access Memory, is a direct access memory that stores our data while we input them. Like for instance, when you type using your keyboard, maybe on a notepad or on a word pad, whatsoever functionalities you inputted are actually stored in the RAM. The ROM is a read-only memory, and it sets to a memory chips that is actually being used during a computer startup. And for that reason, ROM are always non-volatile. And when you do a comparison between a RAM and a ROM, you find out that RAM probably should be called read-write memory, since it's temporary, and actually you write while you read. And so the other parts of a memory devices, which defines whether it's a secondary or primary memory devices. Remember, I mentioned these stuff earlier on at the onset of this class when I listed things like the compact discs, the flash disks, and the hard disks and stuff like that. So now compact discs, these are some of its features. It's portable, read-only. And why is it read-only? Because it is a permanent storage device. Basically, you can say a secondary storage device, and this other stuff you can read of. And also it's recordable. You can have it in the form of rewritable. That is when you have CDR, CDRW. These days you have even CDRW plus. So also be looking at DVDs, and it depends on the size and what basically you want to use it for. And before DVDs we have CDs, which are the compact discs, though it's a little bit different based on storage capacity. The CD, which is the compact disc, can store up to 650 MB, whereas the standard DVD can do up to 4.7 GB. And when you look at the combination of these discs, you can even have a higher storage capacity. So let's come back to the brain box, the central processing unit. I so much love this guy, because without this guy, I think the computer system might not know what to do with the data it's getting. Now, the CPU, which is the central processing unit, contains of 3 basic things. And these 3 basic things, okay, we'll look at shortly, but meanwhile, let's see how does this CPU works. Now, the CPU works in a very interesting manner. It gets your data, basically it fetches this data, and when it fetches this data, what does it do with it? It decodes the data. Now, what does decoding mean? It determines what are you trying to do, what instruction are you trying to pass. Now, on getting to know this, it does what? It executes your command. It carries out the instruction. Now, let's look at the thing that makes up this central processing unit. Like I said earlier, we have the LAU, which is the arithmetic and logic unit. It performs all the calculations you need to do on your computer system. We have the registers, and the register, these are storage devices or storage memory, you can say, depending on what kind of memory. Is it a cache? Is it just a simple storage device to help hold your data as you input? And finally, we have the control unit. The control unit coordinates everything. It sits at the middle. In fact, is the brain box of the CPU itself. So what are the advantages of this CPU? When you think of the speed actually determines how fast your data are being processed. And then you have things like the system clock, the pulses that coordinate this, and of course the unit of measurement. It could be in gigahertz, megahertz, kilohertz. Well, of course I've not seen kilohertz before, but I mean, going forward, you should be looking at things like the gigahertz and the terahertz. This monitor displays your text, your graphics, your video. I mean, when you play game, you see everything comes out clear. But I have to say this, that the monitor is also very dependent on the number of pixels. The higher pixel you have, the better display you get there. And that determines your resolution, whether it's high, it's low, or it's poor. So we also have things like modem. These are actually more of devices that allow information to be sent and received between computer, more like in a local area network, which will look on a different lesson. The modem will actually help in the movement of this data from one device to the other device, and it also have a throughput. Basically, you can say it has a transfer rate. The higher, the better. So I was trying to just beat up to the town so that I don't have a lengthy discussion on this. But I mean, for any question you have, you can actually leave me a comment, or you can send me a mail to my email, sojingene@yahoo.com. And I hope this video has been informative, and I would like to thank you for viewing.